We are the students of Amrutvahini College of Engineering Sangamner from Maharashtra. Our team consists of 4 members, myself Shubham Ugle, my colleague Dhiraj, Naneshwar and Rahul. We have worked on project theme Steel Intensive Quarantine Structure under the guidance of Professor S.B. Kolles. We all know the grave seriousness of the COVID situation and there is toll on healthcare. As India is the second most populous country, we should focus on implementing structures which can be built in lesser time and with economic cost. As it is very important to control the spread of disease, so we should develop the centers which includes the sanitation, ventilation and lighting facility so that the isolation of patients can be maintained and the risk of virus can be reduced. This is the problem statement which is given by the INSDAG, which includes the site location, area of building, minimum use height, building type, minimum spacing of internal columns, and the required economic and structural needs are considered while implementation of project. First of all, we have divided our project in 5 different phases, which includes data collection, functional layout, structural design, bill of quantities, and time of construction. The first phase deals with the data collection. As the strain of virus was new in our country, we first worked out on collection of information based from internet, articles, and textbook. We studied the remain of viruses on different materials which are used to be in quarantine, which are used for construction in quarantine sector. We also follow the guidelines of ICMR and WHO guideline so that effective use of center can be done. Failure and success of every project depend upon consideration. So while planning our project, we are focused on different factors such as space, such as given space, architectural lead, energy, biomedical waste management, use of natural exhaust gas, and overall economy of the estimation. All the components of center are arranged as per the given space. Architectural needs are followed such that the orientation of center is done, that the free movement of air is done, free movement of air should be done with the center, renewable energy is used, and the biomedical waste management is done. The second phase deals with the functional layout, which is drawn in the AutoCAD software. The space given is the space given is divided into 4 quadrants, which which includes 32 beds in first and second quadrants, 38 beds in third and fourth quadrant. The overall capacity of the quarantine center is 140 beds. The beds are 2 meter by 1 meter. Entry, emergency, main entrance and emergency exits are arranged such that there is free movement of patients within the center. All the components are arranged such that they can be accessed easily. The following The following figure shows the art drawing, which includes the area given for the construction of quarantine center, front elevation, side elevation, and typical boundary of the exterior center. Phase 3 deals with the development of structural theme. While we have followed the general consideration which are practiced by the engineer while developing the steel structures at the sites. For designing of the steel truss, we have followed the IS 800-2007. Concrete design is done as per the IS 1456-2000 by using M25 grade of concrete with the mixed proportion 1:1:2. These are applied as per the IS 875 for different loads such as for dead load part 1 is used, for wind load part 3 is used, and that for live load part 2 is used. Earthquake loads are considered as per the IS 1893 Part 1 2016. Support condition of the base are assumed to be fixed. Temperature variation of 15 degree has been considered as there is expansion and contraction of the steel members during the different seasons. Here is the geometry of the structures. The columns, the exterior columns are 7 meter in height and that of interior column are 8.5 meter. The purlins are arranged parallelly to each other and the spacing between purlins 1.46 meter. There are total 25 purlins in overall the structure. Inclined members, vertical members, top chord members, and bottom chord members are designed in the stud pro. Position of the column. The spacing between the column is 6.25 meter, and there are nine number of trusses which cover the entire space of center. This is the truss which is developed, which includes the rainwater harvesting provisions with a diameter of 100 meter of diameter 100 meter to collect the water which can be used for sanitation purpose. Phase. In this phase, we have analyzed the structure in the STAD Pro. This is the rendering view of the STAD Pro, which gives different components and their arrangement. These are the loads applied as per the IS. Blade load are applied as per IS 1875. In dead load, we have kinds of the truss, sulfate of the roof, sulfate of the purlin, and sulfate of the bracing. In live load, access over the roof is not considered as it increases the weight of the structure. Wind load is calculated as per the IS 875 Part 3. In wind load, 7 different factors are considered, which include K1 factor, which is leaks coefficient factor, K2 factor, which is the wind velocity factor, K3 factor, which is the topography factor, K4 factor, which is the cyclonic factor, KD factor, which includes the directional coefficient, Ka factor, which includes the area ratio, and Kc factor, which includes the combination factor. Are loads are developed based on axial compression and expansion of the members by the by which we have considered 15-degree variation, and temperature loads are analyzed in the StatPro software. Here are the loads applied on the nodes of the truss, which are used to check the serviceability and deflection members. All the deflections are within the permissible limit as per the IS 800-2007 part table number 6 for deflection of the members. Limit state of strength of the member is checked in the analysis of the StatPro. Here is the animated model of which includes the different members. The dead load and live load are applied on the nodal and the deflections are within the permissible limit. These are entire steel structure. Wheel of the quantities. Wheel of the quantity is depend upon cost and the quantities used. We have used the square hollow section and rectangular hollow section. 220 by 220 by 5 mm is used at the exterior column. That for interior column, 250 by 250 by 6, 250 by 250 by 6 column size is used for the interior column. Average project used for the steel is 27,705. We have considered 20% additional cost which are used for the erection of the truss, fabrication, enamel wastage is also considered. The overall cost required for the steel truss erection is 32 lakh. Other materials. While designing the foundation column PCC, we have calculated the required cement, sand aggregate and reinforcement which is to be used in the foundation. The required quantities are found out by using the mix proportion, and the overall 368 bags are used for the entire structure. Cements and aggregate are calculated in class and is multiplied by with respect to their rates. Beds. In beds, we have used the prefabricated beds, which is made up of cardboard. As while studying, we noticed that the remain of virus on the cardboard is less. It is of 24 hours as compared to the metal beds. And also, while costing, it is found that the cost of the cardboard bed is 1/4 that of the metal beds. Roof sheet. Galvanized metal sheet are used over the roof, and exterior cladding sheets are used for the cladding on the exterior part of the building. Partition wall. Basically, portable partition walls are used so that the walls can be displaced according to the need so that it can maintenance of the entire structure. This is the pie chart showing the proportion of the cost used for the different components in the building. The large amount of money is required for the steel, which is the 43% of the entire cost. Connection cost is 9%. Concrete ingredients is 2%. Rebars are 5%. Beds require 2% of the entire cost. Roof sheet required 16%, and that of cladding sheet 10% of the overall project. The overall estimation of the project is 83 lakh 18,918 rupees, which is an approximate cost. It may vary according to the seasonal variation or the site conditions. At last, we have considered certain approximate time which is required for following carrying out certain activities while construction of the quarantine center. The execution of the site starts with the site clearance, which required approximate 1 day, depends upon the site condition. It is followed by breaking ground and excavation, which requires 1 day. Foundation requires 3 days, which is followed by construction of the 1 day. Truss assembly is done with the cranes, which requires 2 days. Boundary walls and gates are fixed in 1 day. Erection of column requires 1 day. Completion of the shade will be done in the 2 days. Partition walls are provided by using 2 days within the center. Heat protective coating over the roof is provided. Electric and electric and lighting facility is provided within the duration of 1 day. Plumbing 1 day. Finally, finishing and cleanup is done within the 2 days. This is approximate cost which is to be required for the completion of project is 20 days. The duration of project is represented by using the Gantt chart for checking out the dependency and independency of the construction activity. While after the after the preparation of the Gantt chart, it is found that all the activities are dependent on each other, so that there is no overlap on the activity. Approximately, we have considered that the execution of the project should, if we start it on 1st January, after completion of 2 days, it will be completed on 20th January, and the overall duration of the project is done within the 20 days. At last, I would like to, at last, we the students of Amrutvahini College of Engineering from Maharashtra are thankful to INSDAG team and also respected jury members for giving us opportunity to participate in mashing on proposed project on steel structure and presenting it in front of you really help us lot to getting the best experience which is to be done for the project. Thank you, sir.